Yeah. So so including me and Dr. Sha Cao from Biostatistics Department. Sha, can you say hi to everyone? Yeah.
Hi everyone, this is Sha. Um, I am an assistant professor in the Department of Biostatistics and Data Science in IU School of Medicine. And my own research interest is in big data analysis and data science and the bioinformatics. So basically application of the machine learning algorithms into the analysis of biomedical data. And I'll be happy to teach you guys some basic R programming skills, very, very introductory tutorials, and hope that you guys can learn something from this session. Thank you.
Yeah. And then we'll also have Dr. Li Chen. Li, are you here?
Yes, I'm here. Can you hear me?
Yeah, I can hear you. Yeah. Hi. Li.
Hi. Hi, everyone. I'm Li Chen. I'm a assistant professor from biostatistics and health data science. I'm interested in bioinformatics and computational biology. In the incoming, I guess, in the incoming course, I'm responsible for teaching for visualization purpose. I'm looking forward to working with everyone. Thank you.
Great, thank you, Li. And also we have Dr. Yijie Wang from Computer Science Department at IU Bloomington. So Yijie, can you say?
Good afternoon, guys. Yeah, I'm Yijie Wang. I'm an assistant professor in Lottie School at Bloomington. So I'm in charge of, I think I'm in charge of teaching about Python basics. So yeah, looking forward to teach things with you guys. Yeah, thank you.
Yeah, thank you, Yijie. And at last, I'm Chi Zhang. So I'm from Medical and Molecular Genetics. I will kind of do major coordination of this course and with Elmer. And also I will kind of introduce more about the kind of thank you. And definitely, I will introduce kind of R, and also hopefully I will focus more on kind of illustrate how to use R and Python to do research, and give you some like real case examples. And in addition, so we will have a very important person, Mr. Peng Tao Dang. So Peng Tao, can you say hi to everyone?
Hi everyone, nice to meet you. My name is Peng Tao Dang, and currently I'm a PhD candidate student in Professor Zhang's lab. If you have any questions about anything, please email me. Thank you.
Yeah, cool. Thank you, Peng Tao. So actually, Peng Tao is a very kind of a really his background is software engineering, and right now he is a PhD student in electrical computer engineering, and he is to me, and he is the student who I have met who is kind of with the best skills in computer science, in R programming and Python programming. So he I think he knows he can solve every question. Yeah, so just feel free to email him, and also if you need and if you want, also include me in the email, and if you have any questions. So and then we'll have a syllabus here. This is rough syllabus, and sorry about that. So you may find that some days we will not have this workshop. The major reason is that so majorly about time conflict, and but we tried our best to optimize this syllabus for every to make it can include as much material as possible. So our plan is that today I will majorly just introduce the team and majorly talk about the R, kind of a very beginning part of R, about the program language, and also about the very important thing we want everyone can install. If you are interested in hands-on programming and especially using R, so I hope everyone can install it to your laptop, to your or desktop, or yeah, and in the next few lectures, Dr. Sha Cao and Dr. Li Chen and Peng Tao and me will introduce some R basics, and we will also illustrate some. We include, you can see, some hands-on courses, and these hands-on courses are about kind of just a revisit or review of what we have talked about in the past days to make sure everyone to solve the questions for everyone, so that during the kind of normal lectures other than hands-on, so if you have questions, you can leave it for hands-on, or you can leave it for at the end of the each lecture. Okay, so and also, so you can see that here we will including several, other than the programming skills, we will including like several kind of examples of computational biology research by using R. And I think at last, I hope that in one of the hands-on Python programming course, we will kind of also illustrate how to use Python to do some kind of to solve some specific topics or specific questions in computational biology or bioinformatics research. Okay, so and then I think so everyone, I think every instructors are here. So and yeah, so and I will in the further part, I will take care of the introduction for today. So Sha and Yijie and Li, if I know you're very busy, so if you have other arrangements, feel free to go. Yeah. So and so then let's start from some today's materials and topic about just let's start from some for some warm up of our programming. Okay, so actually my slides were not kind of or some of my slides were not originally made by me, and I just adopt the idea from some other introductions, because the reason I want to mention this is that actually there is quite well kind of organized tutorials and also introductory materials for R programming and Python programming. So you can easily find it online, and easily find YouTube kind of videos to introduce, and like online courses, and also you can find it a lot of slides, and also hands-on books, something like that. So hands-on books. So and then why R? So the reason I want to use, we select R as kind of the first, the beginning, the entry level programming languages that we consider. So R can be, to me, based on my experience, R is first, it's very easy to use, and it's a very popular environment in statistics and the machine learning community. And I think so for high school student, for people and college students, young college student, at your current kind of academic level, you haven't learned a lot of like advanced mathematics, statistics, and also algorithm and the computer science kind of the principles and the programming skills. So at current stage, but definitely, I believe some of you may be very professional in programming if you have learned this a lot. But to most of the students, so based on the general kind of the regular kind of educational track, so you haven't been exposed to the kind of highly intensive programming related kind of topics. But R is the good thing of R is it doesn't require you to have extensive knowledge in programming, in mathematics, in statistics. It can serve as a simple calculator, or it can serve as a way for data visualization. It can serve a more flexible way to edit a kind of an Excel data table, and also can help you to do some computations on the table. So basically, it's a kind of it's use command lines to enable operations on matrix and also more general type of data, or just the data tables, or table-based data. Okay, and also it can kind of enable a lot multiple different types of operations, kind of mathematical operations, and also it's open source. It's a fast growing ecosystem, so a lot of people are contributing to R. So because like for me, for example, if I develop a certain algorithm can solve a specific issue, and I may write it into a package and build it into a function and upload it to the R server, and everyone who want to use this capability can directly download my package and use the function. And a lot of people are contributing the system like me. So, and also they have, like mentioned, they have packages for almost everything, like including data processing and cleaning, data visualization, and also like kind of write articles and slides even for that. So I think we will cover this a little bit in the future, and also the newest machine learning algorithms. And definitely there are some alternatives, but I listed here due to I think it's good for everyone to know this. So R is not only the kind of computation kind of the machine learning or data science programming software. So there are like Stata and MATLAB, and also Python. Python is another open source, and we will include it later. But Python is actually more like a general programming language, not specifically developed for to optimize the data analysis. But Python is with more general purpose, and it's kind of even faster and also more flexible. And also another is Julia, so it's a very new language, and also it's faster and with increasing popularity. Yeah, so. And then we want to, very important thing, I think for today's goal is we hope everyone can install R. So if you are interested in this, and because I can promise that the process won't take a lot of time and won't make you feel suffer when learning R programming, but so I hope that if you are interested in that and want to know a capability, can better analyze your data, visualize your data, and even write your codes to even build some R's product. I will show it later, so some examples later. And install R, and try install RStudio, and also try some functions. So let's go through the process, okay? So here
Hurry up and close the TV.
Hello? Any questions? Okay, if not, that's okay. So so here, this is a most straightforward way is to install R is for the, you can go for Cran, just go for the Cran data Cran website, and you can Google Cran. That's okay. So you just Google Cran. You will see this is the first kind of website pop out. It looks like this, and you can download R for Linux, download R for Mac, download R for Windows. So I think if you are okay, just download it and follow the installation instruction, and the downloading and the installation may take a few minutes. So I will keep my introduction, and but you're just feel free to install it while I'm presenting, okay? And also this is how the R interface looks like after you install it. We will show some examples later today, but may not a lot, because I hope to leave one day for everyone that can install R and can do some warm up kind of just try some cases with R. So it's you can think you can say it. This is a very simple like a calculator, a super calculator, right? And it enables a lot of different type of it enables a lot of different types of operation to handle numerical calculations, and even to solve equations, and even to kind of visualize functions, something like that. And but we will show more details later. And this is the installation part of R. And also another thing is included in my slides is called there's RStudio. RStudio is a better version of R. But when I was learning R around 11 years ago, at that time RStudio, I think there was no RStudio, and RStudio was not very popular at that time. So I didn't use RStudio. This is and then later on, kind of during my programming, so I don't use RStudio a lot. But here, this is RStudio may make things be more kind of looks like more professional and better looking, but basically the thing are the same. You see that here, this is the RStudio, how RStudio looks like, and this is how simple R interface looks like. They just have a more kind of blocks here that can help you to visualize the data. For example, if we want to put one put two variable, and just put two variable, and you can say A is 1 to 10, and B is 1 to 19. And if we plot A to B, plot AB, so we will say, oh, this is A, this is B, how their plot looks like, this scatter plot looks like. But similarly, if in our interface, if we put the same thing, and you will say, okay, if we plot something, they will pop out. window. So there will not be a lot of difference. But here you see that here they have an environment. So inside this environment, what variables there are. So some more better statistics and your history. And also if you want to get a new R script. So here, if you want to open a new script, it will pop out like a small window. But here, if you want to do it, you can just put to this block. And this is the kind of console, and this is the R script you are writing. And also it enables you to open multiple R script one by one and make it be on different kind of tag. So it's easier to use actually. So I think this is a more better for, to me, I think a very interesting thing is that most of my current students are using the RStudio. So I see a question. So pick one to download, or pick should download all the three. So it depends on the system. If you are asking about the download of install of R from the CRAN, so download, if your system is Linux, download Linux. But I think R is encoded in most Linux. And if you're using a Mac, you just download R for Mac OS. And if you're using Windows, your system is Windows, you download it for Windows. Okay, so you just select the proper version that matches your system, computer system. Okay. Yeah. If you are asking R or RStudio, so you first download R and then download RStudio. So RStudio is like I think this. Sorry, I'm not very professional in RStudio, but there's not a big difference. There's no difference actually. But to me, by my understanding, RStudio is just makes R looks better. Makes the interface of R looks better. So you should first download R and then later on you download the RStudio. Okay. So first download R and install R, and then further you download the RStudio. Okay, and use the RStudio desktop free version. And we don't need this pro version. We just download this free version. Should be okay. Okay, RStudio desktop and download for Windows. I think, yeah. And there are also Mac version, and also for this specific for different Linux version, you download it for different Linux version. Okay, I may type in these two websites in the chat. Okay, this is RStudio and this is CRAN. So yeah, you download R plus RStudio, like Peng Tao mentioned. Yeah. Okay, so and then go back a little bit to this, and this is just a kind of inside of the R. So there are some examples. So for example, we use we change it a little bit. So change it to this one. So we can try this, install the package. So, oh, sorry. So it's like the, yeah, it's this one, right? So for example, if we want to install a package, so it kind of help you to install package. You can after getting R, you can try this, but this is not a kind of very important thing. So just an example of how to install a package, okay? And then you can use a library, like I mentioned, to get this model, kind of get this model, you get this package being uploaded. So, but today we will not kind of use this to illustrate a lot of, to illustrate the function of it. But later on, we will definitely introduce what this package can do as an example. Okay, so just one example of how to install package. So this kind of all the installations you may need: install R, install RStudio, and later on when you need specific analysis, you may need to install certain kind of packages. And also there are some resources for learning R. And first there is on the CRAN website, so you can see there is a R introduction book. And a simple way is that from the CRAN, just from the CRAN website, you can go for menus and you click the PDF here. it can get you to this 105 pages of our introduction, and including it's already comprehensive enough. It's a very good version. So for you to kind of to go through what can be done with R, and you see a lot of them are like command line. So you don't need to do a lot of programming. So kind of okay, we type in this, type in this, type in this, type in a lot of lines, and then click enter, and then okay, it goes through. It kind of may return something. This is normally when you do programming, but for R, it's kind of more flexible. It's like a script based. So you just type in one command, it will return you something. Type in one command, it will return you something, and make things be simple and straightforward. Okay. So, and then also there's some other resources, and this is we will use this a little bit later. So this is from our cookbook. So I also type it in the chat. In the chat. So our cookbook is even more comprehensive than this 105 pages introduction from R. Mm-hmm. Oh yeah. So if your question is the slides, I will upload the slides later. So to a GitHub link, and you can find those slides. Definitely, it will be available to everyone. Yeah. Mm-hmm. Yeah. So and for this specific web, this is just a website based our introduction. You can see some basics, and kind of enable you to try kind of R like so. This is a SQRT2. What it means is square root of 2. Definitely you can do it square root of 10, square root of 100. And also there are some encoded kind of constant like pi. So we know pi is with a certain value. And also you can use print sometimes. So for example, if we have put A here, but you can also more rigorous ways to show print A, it will kind of print A to on the screen. Okay. And also, there are some other ways, some like a matrix to build a matrix. This is from here. This means a vector from 1, 2, 3, 4, and the matrix means you build this into a matrix of two rows and 2 columns. But then in the beginning, when I was learning R, 11 years ago. So my question is, there are so many commands. How can I remember those? So one way is that, so definitely there are some books. So there are some books and some resources. You can easily find the R function list. So if you search for R function list, you will find a lot of kind of a good function kind of explanation and the list. And also, but sometimes if just simply if their explanation is not very good, it's not a lot. So kind of on the list. So for example, like here. So here is like a R function list. You can just simply kind of Google R function list, and then there will a lot of pop out, and you can say, there are so many functions. But sometimes you search for, okay, I want to do what? I want to do square root. Okay, if I don't do compute the square root of your numeric data objective. So it's this one. Okay, but further on, if you want to use how to use it, so just mention this. So how to use it? You can just click question symbol and SQRT, and it will pop out in the. So I have a split screen, so it will directly pop out. So about this square root, how to use it. There are some examples and there are some explanations, and definitely you see that. So we can do, for example, just for square root, we can do square root 1, square root 2, and also we can do square root for a vector, and also we can do square root for a matrix. It will take square root for every entry. So this is makes things be very convenient, right? Mm-hmm. So so that's why I mentioned, R, you can regard R as a supercalculator. If you don't want to learn a lot of programming, you can think this. Okay, you can regard this as a calculator. Yeah. So and another thing is here. So and then there are also some advanced R. So like here, so there are some advanced R programming tutorial. So definitely you're interested in, and yeah, and if you're interested in, you can definitely check those. Okay. Yeah. And also there are some sources for R data visualization. So we will go through one specific one. I will show you some, it's a great place to showcase what R can do on visualization. But here is just some practical introduction like of ggplot. It's a very good function for the for visualize different type of data. It's called ggplot2. So if you Google ggplot2 and Google image, you can see different type of data image can be plotted by ggplot2. So like some scatter plot, like some scatter plot to show some correlations, and some of this type of called bubble plot. Some not only the point but also the size and also the class, the color of the plot. Each point, each bubble shows different meaning, right? And also there are kind of different curves and the range of the curves. And even they can have some like this density plot and this bar plot. And also very important thing is definitely histograms and something like histograms, some of the spectrals, and this shows some different type of plots can be plotted by using the ggplot2. So this is the ggplot is a kind of a very comprehensive function, but it's relatively more advanced. So I think Lee may cover it or may not. I'm not sure. But before ggplot, there are also a lot of cases that can be used. But ggplot may need some programming rule. But at least what we will do. So this is what I think we will do is for some functions may need some variations, may need some kind of programming rules. We will provide a full example codes so that in the future you can replace certain kind of the input with your data and make it be possible, kind of make the analysis to your own data be possible. Okay, and for simple cases, I just hope you can kind of remember that and know how to do it. Okay, and then also there are some in-depth discussion of R packages and also from kind of an economist guide, because also actually even I'm a computational biologist, but recently I'm also dealing with some economy data. So maybe I will show some cases later. Yeah, and also some other resources, and also there are some extensions of R. So like using building a Shiny app. So Shiny app means so okay. So so for R, so it's let me find a Shiny app example. So we can make some programming, right? But how to make it be useful to everyone and make it into a user interface? So we can write it into, so the under the background programs are all our algorithms. So some functions written by our group. But here to make it can be, for example, if I want to let a physician or biologists can use our function. If I send them a lot of codes, they may feel, oh, this is too complicated. They just will give up. But if we offer this to them, this data set, this website to them, so and it will be kind of relatively easier for them, right? So we can enable kind of a browse and kind of download the data, upload the data. So this is here is this maximize upload exceed. Okay, so but whatever it can enable certain uploading and do certain analysis, and then this may give you a certain output. Okay, so this is just a kind of using R. You can just example is you can write some interface to enable the kind of the visualization and build a web server for your the developed tools and all functions. And also there are some like Shiny is not a the Shiny is I think Shiny, some of the functions are open source, but definitely for the full function of Shiny, you may need to purchase some they may need some purchase. But for some simple, especially at the current stage for us, when we develop some web servers, so most of functions are free. Yeah. And but the open source, so Shiny, if you pack it, so normally when I develop Shiny apps, so what we will do is we will put all the source code to the GitHub. So that means what we developed are open source. But if you when you develop a Shiny, you just release the Shiny app, so kind of the source won't be released. So you also want to release kind of your original codes. Yeah. And Also, another thing is R Markdown. So R Markdown basically, the basic idea is that you can use R to, like I mentioned, so we use the R to write some R Markdown. Okay, so we use R to write some like the website. We can use it website. Then even also we can use it not only to write the kind of some apps, some online apps. We can use it to write some like kind of the explanation or the tutorial of our functions, and make it can be directly to write some beautiful kind of handbooks or something like that, and also to make to use it to use the R Markdown to build into kind of a certain kind of records, yeah, and of the data analysis approach. Yeah, and we will illustrate this. I think if we have time, we will illustrate how to use R Markdown later. But I think in the in this summer in the research at my lab for high school students at my lab, they will use R Markdown to kind of to record what they will do during their programming, because we in my research we need a lot of programming there. So, and also the last part is RStudio cheat sheet, some kind of how to use RStudio. So then later on we'll use this R gallery to illustrate. I think most of people at current time you have already installed R, but today later on we will show some example codes, but to give people more time to complete the installation. So meanwhile, I think we can do some illustration about, okay, what type of data visualization we can do with R. But definitely we'll introduce the details of each type of plot later. But here I just illustrate, okay, what we can do, what type of plots we can do. Something like here, visualize, it's called violin plot. Just for example, okay, if we have for example, if I'm dealing with some economy data, so I have the people's income from different city, so I can plot them with kind of plot their distribution as this violin plot, and here each violin you can consider, and here this is first this is type of box plot. We can plot this like box plot. Each box shows the kind of the data distribution of reflects the data distribution of each kind of condition. And for example, if we consider this as different cities, so we may have the people's income of different cities. It shows that the trend. So, but definitely we will introduce more details later. And also there are some we can use that to plot histogram. Histogram is more straightforward. It just shows the kind of the distribution of specific data. So the x-axis is just basically the x-axis shows the value, y-axis shows the frequency. The higher bar here means that, okay, there are more kind of the higher bar here means there are more kind of incidence with this value observed. It just basically shows the distribution of the data. Okay, and this is just some simple kind of plot. And then later on, another plot type is called scatter plot, right? And we show that here is, okay, we have some observations here, and we have some observations here. And but on the x-axis and the y-axis, we can show this scatter plot shows the dependency of two data. Two variable, actually, the dependency of two variable or two features. So for this feature, we observe. So this point here means that, okay, we observe the one incidence or one observation, and with the axis value is like around here, and the y-axis value around here, right? This is straightforward, right? And but even on x-axis and y-axis, we can set some bonus kind of visualizations, including kind of their frequency, and by histogram, their frequency kind of characterized by the density function, density curve, and even their frequency characterized by box plot. And this is a kind of a very from just like a data analysis purpose or data visualization purpose. You can also do it by Excel, right? You see that a lot of these figures can be also done by Excel, right? So for example, like Excel, you can also plot this type of, how to say it? To me, it's just a multiple kind of overlapped density plot or box plot or histogram. Yeah. And they call it ridge lines. Oh, very good name, ridge lines. And also for correlation analysis, later on, I think Dr. Shatov will introduce some correlation analysis, and meanwhile, and later I will also introduce how to use correlation analysis in research. And here just shows the dependency of two data. You can see that clearly here in this data set. We see that they're like a group. There's like a group. They form different correlations, and the package raw mixer rag. So what I let you install is just directly a package to solve this, kind of to identify, if they form some different dependency. But whatever this scatter plot shows, tells you, okay, there are some, this is, for example, the length, this is width. So this may kind of is a sepal width and sepal length of several plants is shown. So you can see, okay, several plants, they have the sepal length and the sepal width have this dependency, some have this dependency, right? So this can just help you to visualize, and when you want to explain this data to, for example, like in your current research, if your professor gave you some data, you can use this way to visualize the data and explain it to your professor, and how the data looks like, and what your next step kind of interpretation or further analysis plan. Okay. And also these are multiple ways to show the scatter plot with changing the color, changing the shape, changing the lines, length width, length color, and the symbol color, simple size, and even the line type and segment type, and also the point, the point size, the point shape. Yeah, they have different ways. I think there are many tricks to make the visualization looks better. Okay, and also there are some ways like I even don't know they have the radar plot in R. So, but you can like show here, we can plot a radar plot, and the good thing is that it's highly flexible. It can make you to plot in different shape, in different color, and make your report really looks beautiful. Yeah, and if you click there, you can see there kind of it's not hard. So their function are already shown here, right? So I'm not sure if I can do this now, but let me try. So okay, so we should install the packages. This package, install package. And then try if I can use their function to show the, we didn't see the, we should library this. We after installation, and we upload this package, and then we get the data, and then we see if we have this reader plot. We have this reader plot plotted there, right? And similarly, so for this example, so we want to plot this. So just want to try it. So we can do the same thing and Ctrl+C, Ctrl+V, and you can get this plotted. It's just several simple command line. And in the future, if you understand how this use, so you can change it to your data, right? And actually, the underlying inside of the data just looks like this. This is just the data. It's a table, but it makes the table into some beautiful visualizations. Okay, so but definitely Lee will introduce more details later. I don't want to take his part. Okay, so I just want to show you some kind of capabilities. Okay, and we don't go this one by one. Okay, we'll just go for some more kind of fancier and more kind of complicated case like maps. It can help you to plot maps. Even for this type of map, it can help you to make it be possible. Okay, so there are some very powerful functions to enable the plot of maps. And actually, this is one. So I mentioned that I also work on some economic data. So it's the reason is I work on the spatial data analysis, and the geography and the kind of economy is very important, a very important topic. So what I'm working on, yeah. So hopefully in the lecture at June 21st and 22nd, I can show some examples. And also we can add some bubbles. This is not shown there, but we can see codes. So we can add some dot plot onto a specific map, and also make this be an interactive map, can be kind of enlarged and zoomed in and zoomed out. Okay, and also there are some this here like ggplot2. ggplot2 has a lot of better. It's a kind of form a subclass of data or visualization ways. So, and also there are some like this called this is called a Sankey diagram. So this is a very beautiful way to illustrate how the relation, the relationship dependency of the data or subclass, like this is what waste are go to which part, and from kind of which branch, like industry, commercial, and this is like electricity grid, and the thermal generation, house gas, and then this is some specific type of specific type of waste. I think this is for the kind. Definitely have some meaning. So it's like for the kind of agriculture waste, nuclear and wind. So yeah, they may have some specific meaning of this, but you can also find the chart code of this. So if you want to find the data description, you can go for the, and also this here you see that they have just several command line to download the data from a online source, and this is the online data source here. Yeah. So yeah, but today I just want to illustrate the kind of the power of what we can do here. Yeah, and also there are some ways to plot the kind of using this is called the hierarchical edge bundling to show the kind of how the dependency of different units or different elements. So you say, oh, these two should have a dependency. You just add a kind of a specific link to them, and also they have a kind of a link with a different level of edges. Yeah. Yeah. So just have fun to try this, and there are also example codes after you install R, so you may try this as what I did here. And also, but keep in mind that, so sometimes, for example, if they need to, the library, so two very important, so the only thing that may block you try this kind of, their examples is you need to, sometimes you don't have the package installed. You may need to install the packages. So like I showed here, so I used the installation. It's called install packages. What? So this is I type it in the chat. Oh, sorry, I type into. I should type in everyone. So I type in the chat. So install packages, and the packages should be the ones you want to, and the library is the packages. Library is just like a load the packages. So for any example, like I showed there, so for any example I showed here, so if they use a specific, if they use a specific package, so for example, like here, so if they use a specific package, you may need to relate to install the package first. So for example, here, this package said, oh, I don't have it, so I need to install them. Right. So any questions about the package installation? If not, you will see, if you run this code, you will say, oh, because this package is very have a lot of function, it will install a lot of things. So, and then they will have some MD5, some checks to check if they have completely downloaded and installed. And then this may, sometimes some big packages may need a lot of checking, okay? And also definitely some warning is okay. And if you want to, the only way to check it, whether it works, you can just do the library to check if it can be successfully loaded, or there are some error. So, and like this one. So we may kind of specifically install that. And to say that if it can, no, it doesn't work. So, but later on but this is just one example. Sometimes I have some version issues, but for these issues later on, if I want to kind of, if we really need that, so we will definitely make sure that you can make this can be installed, and definitely ask Peng Tao if you have such questions when you try R. Yeah. And I see a question, if I want to grab code from under one of the plots you showed us, some of the cutting and the paste works, but some other I have to do install things. Yes. So the question is like that. Sometimes, so it's only about the, like I showed here. So just go back to a simpler, just go back to just for this example. So yeah, this is very commonly used package, but I don't know why it doesn't work on my computer right now. But let me see if I can use it on different version of R. Package of yeah, so the newest version should be okay. It's already downloaded, but it's a higher version of it. Okay, so but I think to save time, we will not focus on this very complicated case, but go for a kind of simpler case. So for this, I think they may need a called a tree map library. If I have a tree map, I don't have a tree map on this version. So we install our packages and install it. And then we library it. And then if we go back and use that, and you will see, okay, we have this can work. So the mechanism is like each of the code may contain several things, several components. One is visualization, one is getting the data, one is getting the library. So most of the example codes, the library contains the example data. So once you install the library, it will automatically contain the data. But for some other examples, the data are kind of from some external resources. So you may have to download them. But also encoded in their example codes. So the only thing you need to install is to make sure you have the library installed, the package installed, and you upload the library, so the package by using library command. You got my point? Okay. So that's probably the kind of but today is just the purpose is just for show you some examples about how the power of R in visualizing data. So then we have a few minutes left, and I suppose everyone has if you want to install R, you have finished the installation. But if in case you have some questions, just feel free to email me or Pengtao. Okay, and later on we will just use this as an example. So this is about R. What this is like I mentioned, the R cookbook. This is about R cookbook. I put it also in the chat. So this is about R cookbook. And the first chapter is about getting an installation of R and R Studio. So there are more kind of if you kind of install R and R Studio is not so haven't done this yet. So you can just check this for detailed examples. But I think just always keep in mind that this programming kind of platforms or language are kind of updating very frequently. So some old tutorials doesn't fit the current kind of version, but the interface doesn't look like the same. But most times they may work, but sometimes they may not work. You may want to check the most updated kind of introductions. But for the programming rules, programming language, they are almost always fixed. So let's just try some examples here, okay? So to make it be rigorous, I think better for me to use R Studio, because since everyone will use R Studio, I think. So just try some examples here. Okay, so here is like I mentioned here, you have the kind of open file, and you can new file, you can open a new script. So today, due to the time issue, so we don't introduce the working directory and working directory issue. We just show some basic functions of R. But later on, I think in Sha's in tomorrow's lecture, Sha will introduce uploading data and writing data. So you may have to define some kind of to specify which directory, which locations on your computer you want to read the data in. So there are some mechanisms, but it's for tomorrow. Okay, so here here you can just on the R basics. So you can on this R cookbook website, you can just copy paste here, and then you can just copy paste the command line in, and and also here you have I think there is which one, source? Yeah, you click source, so it will show you what run. If you run it, it will run what you put there. And also here they have the history. Okay, so And also this is just making a matrix. And also there are some ways to print some something. So to print a certain character, so you also click run. You will no, you see here there are some arrows. So but oh yeah, this is since you cannot directly print. So like this is I want to print something, but I want to directly put some link them together. But this is it doesn't work because this is not the rule that you should print. But if you want to print them, one way is to split print them. Kind of you print them, but here I leave it here. This tool should be able to print, right? But if I want to print this, oh, there should have some problem. Why is this? They need a minus, they need a plus, because this kind of regard this command is not closed. Since if you put only one of this symbol and this here is the arrow. So because the reason is you missed one here. So just put this back. And you see the radiance. But the most rigorous way to enable the print is they offer it. It's a kite. You can directly use kite to link them together, and then do the print. And okay, you see the 0 occurs at what the radius.
Better for wrapping up a Nintendo Switch at the end. So
sorry.
I'm gonna get some points so I can win. Me too. I want those Target gift cards that we're putting up there too.
Okay, I can mute. Yeah, that's okay. So and this is kind of it's called a Fibonacci number, right? So you know what is, you have learned this before, the Fibonacci number. So it's just 0 plus 1. And 0 plus 1 equal to 1, 1 plus 1 equal to 2, 1 plus 2 equal to 3, 2 plus 3 equal to 5, and the kind of every one equals to the one kind of the sum of the previous two. Okay, and then you can cat this. You define this, and you cat this. You kind of make it into a sentence. And this type of operation enables you kind of to integrate numerical kind of computation results and with characters to make this into a certain sentence, so that it is useful. It's not useful for data analysis, since in data analysis we don't need this kind of characters, but it's good for you to write sometimes if you want to write some report, it will have certain ways to kind of directly use an R to generate that. Yeah. And then there are the second part is about set variables. So we haven't, you see that for all of this, it's all about print, cat, and nothing will be left there. So for example, here it says the environment are all the only one we have defined is a fib. But A and B were whatever I defined earlier. So here the 2.2, the further part is about how to define variables. The reason we want to define variables is that sometimes we want to do sometimes for some data analysis, for example, if we want to compute 1 plus 2 just equal to 3. We just want to compute it one time. So it's just put it there and then we can ignore it later. We can just ignore it then. But sometimes if we want to, especially for data analysis, we want to do multiple different operations to the data. We don't want to make the data kind of be only show one time and then we do the analysis and then nothing left, right? We hope to leave all the results there, or at least leave the data there so we can analyze it with different ways. So that's important to define a variable and make the variable be kind of contains the data you have. For example, if I want to make how many numbers here is 10, right? So we want to make a matrix. It's just a matrix fib 2, 5. So it's 2 rows and 5 columns, I think. To give you 2 rows and 5 columns. If this is your data, right? If just imagine if this is a data you observed. So sometimes you want to, okay, I want to plot the data. I want to plot the first row versus the second row. So if they have a certain dependency. how they depends on each other, right? How the kind of the changes depends on each other. So if we do the first row and second row plot, okay, this is we can plot it. But each time you have to remake the matrix, remake the data. So the most convenient way is you define your data to this. It's kind of you assign this one, you assign this matrix. You assign this matrix to a variable named data. And here data is what? Data is you see here, data is the data. You click here, you can see what data looks like, right? And I think tomorrow Sha will introduce more details about some real cases data. But here's how it's kind of you use this way to define a variable. And here a variable is data. So there are multiple code. Today I just show some cases, but the systematic introduction of those codes will be in tomorrow's content. Okay, so here we will use mode to say, oh, data is numeric, right? And also I think we have I think it's class maybe. So because I haven't, class. It's a matrix and an array. So it's a matrix and also an array. So so that means data is current data is a numeric matrix, and actually all the matrices are array. So and then we can do a lot of operations to the data, including we can do the, like I mentioned, so the take square root of data, and also take the kind of even we can do cum sum of data. What is cum sum? We can do, so the cum sum means the first one is the sum of the first element is 0. The second one is the sum of the second one. This is the second element. The third one is the sum of the first 3. The second one is the sum of the first 2. The third one is the sum of the first 3. The fourth one is the sum of the first 4. So it will be more straightforward to cum sum fib. So you can say, oh, this is the fifth one is what? The sum of the fib. Currently the fib is 1, 2, 3. So here's a fib. Oh, so here if we show the fib is 1, 0, 1, 1, 2, 3, 5, and the sum of their first 4 elements are 4. Sum of their first 5 elements are 7. So you can use a cum sum to this function to get their cumulative sum. Okay, so this is just one example of the questions, and also I think if we have cum product fib, oh, but because their first one is 0, so the cum product is all 0. But if we change it, we this fib minus 1 means we remove the first element, and we do the cum product. It just shows the cumulative product of that. Okay, and but you see that I didn't mention, but I did mention it today since just want to do some kind of examples. But there are some ways to show, okay, like fib. If we want to get the fib of certain elements of fib 2 is 1, fib 3 is 1, and also we can print the fib 2, fib C 2, 3, 4, 5. So to print there are certain elements, and also if we want to print the first 5 elements, we can use fib 1, 2, 5. So to plot their first 5 elements, and this 1 and the colon and 5 can directly help to generate a sequence that is from 1 to 5, something like that. Okay, so a lot of this type of operation are included in the R cookbook. If you are interested in this, you are feel free to read this and try this. But from tomorrow, Sha and on tomorrow and on Thursday, Sha will introduce more about this kind of functions. And on Friday, so I and Peng Tao will do some hands-on kind of works. Yeah. Mm-hmm. That's all.
Thank you so much, Dr. Chang. Students, I have an announcement for you.
Mm-hmm.
On your Zoom settings, there is a place for reactions. You're going to find the applause button there, and we want to send a big applause there to Dr. Zhang. That's super.
Super. So, thank you. Yeah.
That was just deeply appreciated.
Mm-hmm.
High school students and high school programs, remember you have a 1 p.m. meeting, and please make that transition soon.
Mm-hmm.
I don't know if Dr. Zhang has time for questions and answers, but the undergraduate students, you're welcome to stay on. I don't know how much time he has, Dr. Zhang.
Yeah, but yeah, feel free to. You can. I think you can. Thank you. I think you can, because in chat a lot of people are typing. So thank you so much. You're really welcome, and I really hope that you can learn something from here. But for all the questions, we can leave for Friday. So hands-on session, I think. Yeah. Okay. Good. So I think you should go for the 1 p.m. meeting. So
All
schedule.
righty.
Yeah.
All righty.
Yeah.
Thank you so much. Take
Thank
care.
you. See you, everyone. Yeah. Enjoy. Bye.